GATE 2019 rate process questions. The terminal rise velocity of a spherical shaped solid in liquid obeys the following function relationship, where the terminal rise velocity is given as function of diameter, apparent weight, viscosity, density, etc. So, according to Buckingham Pi theorem, the number of dimension variables can be given by here you need to find first the number of dependent variables. The mu, d, u, w, whatever is given, they are all considered as dependent variables. So number of independent variable pi can be written as m minus n, where n is the dependent variable minus n. What are the most the dimensions of whatever given, like the numbers are depending on what kind of dimensions. Here diameter is length, where weight is given in mass, and density is also you can calculate, and viscosity there'll be the all fundamental units, right? Length, mass, unit time, and current, ampere, etc. So they all comes under n, and m becomes all the dependent variable whatever is there. So here it is totally 1 2 3 4 5. There are m is equal to 5 and n are 3, because the diameter is length, weight is given in mass, viscosity and density. Of course viscosity depends on seconds, so here the unit comes in seconds, so it is 3. Overall it is 2. So number of independent dimensional variables are 2. The steady state radial heat conduction through a hollow, infinitely long zirconia cylinder is governed by the following ordinary equation: 1 by r d by r, r k dt by r is equal to 0, where d is temperature, r is the radial distance. The inner surface of the hollow cylinder is maintained at 1473 and outer surface is 973. The rate of heat per loss per unit length, the rate of heat loss we need to calculate through the outer surface of the hollow cylinder. So the inner radius of the cylinder is given as, so this is the hollow cylinder. So Ri is given as 0.05 and R out is given as 0.07. K is given as 2, and other temperature T2 is given as 1473 and T1 is given as 973. So this is the differential equation which is given. Now we need to solve it. So 1 by R dou by dou R of Rk dou T by dou R is equal to 0. So you can send this to this side, then it becomes d by dr of Rk dou T by dou R is equal to 0, where Rk is equal to dou T by dou R is equal to C1. You can assume as constant. So dt by dr is equal to some C1 by Rk. So if you'll send this dr this side and integrate it, dt is equal to C1 by K integral R naught to Rf, and here it is T naught to Tf, or R outside, and 1 by R dr. So you get C1 as delta T by K into ln Rf by R naught. So you can keep it as it is. When Q is equal to, Q is equal to minus Ka into dt by dr, where it is minus K into area is the cross sectional area, surface area. So it is 2 pi RL into delta T by R into ln Rf by R naught. So this R and this R gets cancelled. So you get minus K into 2 pi into, here it is given as rate loss per unit length. So L will be sent this side, and delta T by ln Rf by R naught. So substituting these values, we get, let's substitute these values. One four seven three minus 973 divided by ln 0. 0.07 divided by 0.05 into 2 into 2 into 3.1. So you get 18,664. Okay. Now, for the next question. A 50 diameter sphere of solid nickel is oxidized in a gas mixture containing 60% argon and 40% oxygen by volume. The rate of oxidation of nickel is controlled by the rate of transport of oxygen through the concentration boundary layer. The rate of oxidation, that is, we need to write it in terms of moles per minute. So this is an important question. This hasn't been explained by any of the other coaching institutes. We'll be solving it. So you have this. This is the diameter of the solid cylinder, and you are passing oxygen. So here nickel is reacting with O2 to give nickel. So you can see the d nickel by dt is half of dO2 by dt. So you need to find this one. So first, if you need to find nickel, the rate of nickel, then you can find the rate of oxidation. So now let's calculate the rate of nickel, how it is happening. Here you can apply from diffusion. J is equal to minus d into dc by dx. So this can be transformed as n dot by A is equal to this in rate transfer. If you'll see, diffusion by delta is nothing but mass transfer coefficient. So K into delta C. So n dot is equal to Ka delta C. You can write concentration in terms of pressure by RT, because concentration is nothing but mass by the number of moles by volume. So this comes from P equal to nRT. So you can write concentration in terms of P by RT. So this Ni dNi by dt is equal to Ka into delta P by RT. So you get this in terms of seconds, mole per second. So to get it in minutes, you need to multiply this with 60. So you get 0.03 into, what is the area given? Area here, it is sphere. So it is pi d square, pi into 0.05 square. I'm converting into meters. So 0.0. And how to get pressure here? Here it is given as pressure. It is 60% argon and 40% oxygen. This oxygen, whatever is there, is going to react with nickel. So here the pressure which is given by oxygen is 0.4 atmospheres, and minus, because as total pressure is given as 1 and 40% of oxygen is given, so the pressure exerted by the, because partial pressure, what it says is like so here it is 8.314 into 1173 into, as atmospheres, you can convert into pascals, 101,325. So total, if you'll calculate, you'll get 0.3 into 3.14 into into 60. So you get 0.058. For oxygen, it is 2 times the rate of nickel. So R42 is equal to 2 into 0.058, which is 11.7. So 0.17. 117. This is one of an important question. Okay. The pressure drop in the granular zone of blast furnace is 300 mm of water per meter of bed height. The bed permeability is 0.8 and the volumetric flow rate of gas per unit area through bed is given. We need to find it out. And according to the Darcy's law, G is given and density of the water is given. So we know Darcy's law is used to find the volumetric flow rate. Darcy's law is generally given by volumetric flow rate Q is equal to KP into A into delta P by L. So this is nothing but the pressure head, whatever is present, pressure, and the bed permeability, you'll multiply it with C. Then the bed permeability here we are writing it as Kp, which can be written as 0.8 into area. Here it is given volumetric flow per unit area. So area is not required, and pressure is rho G into H. So that is delta H by L. L is given as per meter of water. So this is delta H by L, which is given. You can write it as 300 mm, which is equal to 0.3 meters, and this is 1000, and this is 9.8. So you can get the value as 0.8 into 1000 into, you get it as 2352 meter cube per second per meter square. Thank you.